Okay, so we're solving equations of logs, and let's call this type 3, and that is using log rules. So there are 3 log rules. One of them we're not really going to use in this course, but you use a lot in calculus, so I'm just going to put it because there are 3 log rules. So to be complete, the first one, n log base a of x is the same as log base a of x to the power n. I'm just going to write all 3 and then I'll show you an example just with numbers how these work. Probably we should add those to the memorized list. I don't know why I didn't think to put them on, but they should probably be on there. Because you do need to know those 3 rules. And I probably forgot to put them on because to me they're not hard, so I already know them. So I didn't need to really think about them. So let me just show you what each of these mean if we're looking at just a number, for example. So log base 5 of 25. What's the answer to that? Do you remember? What do? We say 25 is 5 to what power? 2, so the answer to this is 2. This is log base 5 of 5 squared, which these sort of cancel, and the answer is whatever the exponent is, 2. Now, this first rule says that if there's an exponent, like the 2, we can move it down in front. That's all it's saying. So you can leave it up as a 2, or you can move it down in front. So in other words, we could say log base 5 of 5 squared is 2 times log base 5 of 5. Log base 5 of 5 is 1. So you can move the exponent down in front, and then it just makes it times 1, so it's still the same thing. So that's the first rule. And so just to remind you, ln is the same as log base e. So that's equal to 1. Ln of e is 1. What about ln of 1? One is e to the power 0. So this is ln of e to the 0, which is log base e of e to the 0, which is 0. Ln is the shorthand for log base e. You can rewrite it that way if it makes it easier for you to think about. And what about ln of 0? I told you before, undefined. You can never plug in a 0 to logs. And what about log with no base? What base is that understood to be? 10. So what's this equal to? 1, because the power of 10 is, so this is the same as log base 10 of 10, which is 1. What if I said log of 1? Any log of 1 is 0, because this is log base 10 of 10 to the 0, which is 0. Anytime you see 1 there with a log, the answer is 0. And anytime you see a log with a 0, the answer is undefined. Well, not really the answer, it just is undefined. So what if we put a different base? Say log base 3 of 3. Log base 3 of 1. Log base 3 of 0. What are all of these? Same thing? 1, 0, undefined. Do you see the pattern? Okay. So that's just a little reminder. So let's go back and use rule 2 and 3 now to show you how to solve an equation. So what is this equivalent to that we've done before? So when we did fractions, solving equations with fractions in it. So just think about fractions for a minute. When we had a fraction, like say x plus 1 over 2 is equal to 5. So we call this type like there's one term on each side and one of them is a fraction, or both of them could be a fraction. How did we solve that? Cross multiply. Now what if there were two fractions? So this one we just did one step, we cross multiplied. So here there was 3 terms instead of just 2, so you can't cross multiply. The only time you can cross multiply is when you've got one term on each side. So what do we do here? Common denominator. What does that do to our original equation? So we find a common denominator here which puts these two fractions as 1, and then we're back to where we started, where we can cross multiply. So that was how we did fractions. If there was 3 terms, we had to combine 2 of them to make 1 before we could solve it. So we did a common denominator so that we had this case, and then we can solve. So logs are the same thing. So those rules that I just wrote down are what are going to, there's no such thing as a common denominator here because they're not fractions. Instead, you can take 2 logs, if there's a plus sign in between them, and make them into 1. And you can take 2 logs if they're subtracted and make them into 1 using these rules. So when they're added, what does the rule say to do? Take the 2 arguments, whatever comes right after the log that's attached to the log, and multiply them. And now you've got 1 log, and we can solve using the rules we did before. When there's a minus in between, or they're subtracted, we divide them. Okay, so we're going to do an example of each of those situations. Yeah, and you won't get a question with them not the same base. So that's okay. I mean, on more advanced, you could. What would you do? You would change the base first so that they're the same. I showed you how to change the base using another formula, but we're not going to see that here. So if you did, that would just be a typo. Okay. So here's an example. Solve for x. Okay, so I've got 3 terms. Remember, we counted terms right at the beginning of the course. How many terms are here? 1, 2, 3. You can't have 3 when you're going to solve. You need to put 2 of them together. It doesn't matter which 2. You could rearrange it if you wanted to. But here are 2 lawns, and they've got a plus sign in between them. So how can we rewrite it? So the log rule for when they're added is to write 1 lawn, or 1 log, whatever it is, to write 1 with a big argument. If they're added, we multiply them. So you write 1 lawn with the 2 arguments together multiplied. So x minus 1 times x plus 2. There we go. So now we have 1 lawn on each side. This is type 1. That's really easy. We called it 1b, which is if there's a log on both sides, they're the same log. You can ignore that part because that's already the same. We need the arguments to be the same. So what would our next step look like? X minus 1 times x plus 2 is equal to 2x. And we would just solve that like we did back in chapter 1. How do we solve this? Expand it, right? Use FOIL, multiply this out. Don't forget the 2x on the other side. Then what? Move the 2x over. I joined those 2 together. So we've got x squared minus x minus 2 equals 0. Just simplifying it. There was a 2x, a minus x, that's 1x. I moved the 2x over, and now we've got 1x minus 2x, which is negative x. There they are. Okay, now what? All to one side whenever it's a quadratic, we either factor or use quadratic equation. Does this one factor? Two numbers that multiply to give 2, and subtract to give negative 1. Like that? Okay. So here our answer is 2, and here our answer is negative 1. Now, with logs, the same as square roots, we have to check our answer because logs can't be negative. So, where do we go to check our answer? What are we checking these in? Never in where you changed it, always in the original. And what are we looking for when we're checking it here? Right, check for 0 or negatives. Because logs, the argument on the log, whatever is here, has to be greater than 0. Not equal, has to be greater than 0, not equal 0. So if we plug 2 in to the first one, we get log of 2 minus 1. Is that one okay? Yeah. What about this one? Or, sorry, ln. Ln of 2 plus 2, is that okay? Yep. And here? 2 times 2? Okay? Yep. You could check your answer and see if it works both sides, but unlike the square root, it actually will work if you've done everything correctly. The square root, you really have to check not just for negatives, but if it works, because when you end up squaring both sides, you can sometimes lose something that will end up working in the beginning. Here you really just need to make sure that it's not negative. But if you solve these, if we had plugged in the 2 all along, we get ln of 1 plus ln of 2 plus 2 is equal to ln of 2 times 2. What's ln of 1? 0. You don't need the actual answer to see that ln 4 equals ln 4 is okay? Yeah. All right, now plugging in negative 1, this one's probably iffy. Right away I see that it doesn't work. Right? You don't need to check in all the rest of the pieces. If it doesn't work in one of them, you stop. So if we're plugging in the negative 1 and we put it into the first one, negative 1 minus 1, that's ln of negative 2. That doesn't work. So what do we call this? Inadmissible, that's gone. We just cross it off. That part doesn't matter, the name, but that's what we would call an answer that we get that doesn't work in the original. It's inadmissible. This is the only solution. So cross off one of them and circle the other one. Okay, so that's if there's a plus in between. The plus are actually the harder ones because you do have to factor or use quadratic equation. With the minus, you just have to cross multiply. You just end up with fractions, so they're actually a little bit easier. So, one with a negative. So there's still 3 terms here. This time I didn't put a log on the other side, so we'll end up using another type 2 when we solve this one. So this is the rule with the negative in between. So let me just remind you of the rule. It says that if we have 2 logs that are subtracted, then we can write them as 1 and divide the arguments. Whichever one's positive is the top. The negative one is the negative exponent, which moves it to the bottom. Okay, so we rewrite this. 1 log, a big bracket, and in the bracket, whatever one is positive, 3x minus 1, is on top in the numerator, and the subtracted x plus 1 is in the denominator. There we go. So now we have 1 log is equal to a number. This is type 2b, which says, how do we get rid of the log in front of something? Not log, no. Good. Good to say that, because I just marked someone in the online course and they did that exact thing yesterday. That's not quite right. So this was type 2b, if we look back, and that is, if you have a log, let's just make a new question here, is equal to a number. You need to get rid of the log. If it was a square root, we would square both sides. If it was a cube root, we would cube both sides. What do you do to both sides to get rid of the log? The inverse is the power function, right, our exponential. So 3 to the log base 3 of x is equal to 3 to the 2. Do you remember? These cancel, so x equals 3 squared, so x is 9. Because the question had a log in it, you would just double check to make sure it's not negative, which it's not. So we're good. Okay, so back here, what do we do to both sides? These are the powers of what function? 2, the base is 2, so we raise these as the power to a base 2. Those are the exponent. Don't write it tiny that you can't see it. But now they cancel, and what do we have? On this side, 3x minus 1 over x plus 1 is equal to 2 to the 1? 2. Now we cross multiply and solve. This is now just a fraction question. So cross multiply. 3x minus 1 equals 2 onto x plus 1. Three x minus 2x equals 2 plus 1. X equals 3. And then again, the original question had a log, so we have to check to make sure that 3 works in both of the logs that were in the original. So we're plugging 3 in. Is this going to be positive or negative, the argument? 9 minus 1 is 8. It's positive, that's okay. And the other one was log of 3 plus 1. That one's okay. That's what we're adding. So that would be your answer. Okay, so I'm going to try to trick you with this third one. A trick, yeah. I just call anything harder a trick. It's not really that tricky. Oh, yep.
Given that the right-hand side was equal to 1.
Yep.
So can you still say that 1 is equal to log 2 base 2?
Yeah.
So then just that way you can set what's in the bracket equal to 2?
Yep. Yep.
But you won't be able to do that for equal to 1.
Yeah. Yeah. I mean, you could argue the same thing anytime that it's like, say this was equal to 2, then you could say, well, it has to be 2 to the 2 over there, but it's a little harder to think about that way. Yeah, and you can certainly do it that way, and maybe rewriting the equation as 2 to the power 1 equals this. That's like called your inverse relationship, and they do that often in school. I just like it this way a little better because it's consistent with all the other types of solving we did. When we have something on each side, we take the square root of both sides, or we take the cube root of both sides. So here we're doing something to both sides so that they're still equal. But the other method that you use the inverse relationship is totally fine. Like 2 to the power 1 equals this. Okay, so tricky one. So write it down. Okay, so how are we going to combine these two logs? Which rule? The divide one. So I see some confused looks, and that's good. That means you're actually thinking about it. So for the people that are thinking about it and are confused, why do you think it would be the divide one? Right, this is not, if we had two numbers, go back to my son in grade 1. I told you the story, right, about him saying his teacher didn't go to university? Oh, well, I'll tell you the story then. He came home in grade 1, he said, "Mom, I don't think my teacher went to university." And I said, "Why?" And he said, "Well, she said when you subtract, you have to put the bigger number first. And you don't, Mom. You just get a negative if it's the other way around." And she didn't know that. And she said, "You have to put the bigger number first." I don't think she went to university. I said, "I hope you didn't say that." He said, "No, I just did what she said, but Mom, she's wrong." So here is something similar to that, in that if we had -3 plus 5, are we subtracting those numbers, or are we adding those numbers? Is this going to be 8, or is it going to be 2? The minus can be second or first, it doesn't really matter. This is the same as 5 minus 3. We're subtracting the two numbers. There is a negative in front of this, so we're actually subtracting this one. Do you see it? Now, I know you'll want to rewrite it when you see that, and you can. All right, you can. And then you can, it's clear that it's subtract. The other way to think about it, and in calculus this will become more useful, is if it's a negative term, that goes on the bottom of the fraction, and any positive terms go on the top. Okay, so that's because what you're going to have in calculus is more than two terms. And all of the ones that are negative go on the bottom, and all of the ones that are positive go on top. So it's sort of an extension of this. So it's good to see that. So when we rewrite, we would say this is log base 4 of great big fraction. And our fraction, the numerator would be 2x plus 3, because that's the positive term. And x plus 1 is the denominator, or the negative term. Does that make sense? Now, what do we do to both sides to get rid of the log? Power of 4, because the log is base 4. So 4 to the log 4, all that stuff, equals 4 cubed. 4 cubed. Thank you. 4 times 4 times 4. So we get 2x plus 3 over x plus 1 equals 64. Now what? Cross multiply. The subtract ones are easier. The multiply ones, you would have to use quadratic equation. So 2x plus 3 equals 64 onto x plus 1.
So it stays x plus 1 before you switch to the negative.
Yeah, the negative puts it to the bottom. It is actually a negative exponent, which moves it to the bottom. Yeah. But the negative sign is gone, because the rule is if they're subtracted, the one that is subtracted. And then just rearrange this. So let's bring the x over. So 64x minus 2x. 3 minus 64. So x is negative 61 over 62. Can we simplify that fraction? The answer is no. Never, you can't if they're only one apart. They won't have any factors in common. Okay, now what do we do with this? Check it. It's negative, so it might be iffy. Let's just take a look. What are our two logs that were in the original question? So one was a log of x plus 1. So if we put this in, you're not going to necessarily figure it out. Let's reason through this. We'll just care if it's positive. Here's a plus 1, and here's a negative number, is that number bigger or smaller than 1? 61 out of 62 pieces. Smaller than 1. If you cut your pizza into 62 pieces, we have 61, not the whole pizza. So this is smaller than 1 plus 1, which would be positive. 1 over 62, you'd have 1 piece left, right? So that's positive. What about the other one? So that's okay. Log base 4 of 2x plus 3, what do you think? 2 times negative 61 over 62. That's a number less than 1 times 2. What's 1 times 2? 2. So what do you think? This is smaller than 2. So a negative number smaller than 2 plus 3? Positive. You could find your common denominator and do it, okay, if you don't want to just reason through, but they're both okay. So this would be your solution. Could they both, could one of them be not okay? Sure. And then what would you say about this particular question if it didn't work? Just no solution. And of course there's many logs I could write that won't work, right? So there's lots of possibility that there's no solution. All right, now last type, type 4. This is a substitution. We're going to use it here. You're going to use lots of substitution methods in your further math courses, but this will be one introduction to substitution. So we're going to start with E. This one's going to be easier than the one with numbers in it. So here it is. Okay, does everyone have it written down? So a substitution method often will appear as, this is a quadratic equation. Do you see it has 3 terms? The first one is a squared. The second one is not a squared, and the last one is constant. So if we were looking at a quadratic, this would be similar, but without the x. What do we have instead of the x in this question that's squared and then that's not squared? So let me rewrite it. If I said this was e to the x squared, when you have 2 exponents like that, they multiply, that's 2x, minus 6 times e to the x, plus 8. Okay, can you see that it's quadratic? Something squared, something not squared, and then a constant term. So we're going to factor it, but I know it looks too weird to factor like that. So this is the substitution part. So we're going to say let, you can't use x, even if you want to, because there's already an x in the question, so we have to pick a different letter. Let's do m. M equals e to the x. So this is a substitution. When you take a part of a function out, you can call it something else, and then you write the m's in their place, just like we would write a number in its place. So instead of e to the x, this will be m squared minus 6m plus 8 equals 0. And then we can factor that. Or use quadratic equation if it doesn't factor. So does this factor? 8 is 4 and 2. We want them to add to give minus 6, so minus 4 and minus 2. All right, now there's a little bit more to it because we do have to go back to the e to the x after. So m minus 4 equals 0, and m minus 2 equals 0. Here they are. Now what do you think we do? We need to go back to the m equals e to the x and write the e to the x back in. So e to the x equals 4. Or e to the x equals 2. We have to solve for x now. This is back to type 2, type 2a, which is an exponential. What do we do to both sides to get rid of an e? That's the inverse function of the e. log base e, you can write it that way, or as a ln. So you take the log base e of both sides. These cancel. We get x equals ln 4. There's our first answer. The second one, take the ln of both sides. These cancel, x equals ln 2. There's two answers. The original question was an exponential. That the domain for that's all real numbers. We don't need to check. You only need to check if it's a log or a radical, a square root, an even root. No, you don't need to check because these exponential, you can put anything you want as the exponent, and it will work. You can have negative exponents, you can have positive exponents, you can have fraction exponents. You just can't plug numbers into logs in case they're negative or square roots. So that's why they're the only ones. You can check everything if you want. But I worry about you checking, because what happens sometimes when you check is that you get your check wrong, and then you scratch everything out, thinking the question's wrong when you had it all right and all you did was plugged it in wrong to check. So you only check with logs if the original question has a log or the original question has a radical in it. All right, one more like this. Let's see if you can set it up. So I'm not going to put e. E's obvious, okay, that it's squared and not squared. I'm going to put a different number in. And then there's a couple practice questions and a couple in the textbook to look at that are different as well. Okay, so we're going to do the exact same method here as the last one, but it's not as obvious because this time we've got a 9 to a power x and a 3 to the power x. They don't look the same. But what is 9? 3 squared. So there is a 3 squared and a 3. So let's rewrite that first. 9 is 3 squared, so that's 9x is 3 to the 2x. I think the one on your homework is 100 and a 10. So 100 is 10 squared. Okay, so here we go. What are we going to let m be? 3 to the power x. So this one is 3 to the x squared. This is just 3 to the x minus 2. So we're going to say m squared minus m minus 2. And then factor or use the quadratic equation. Okay, it factors. Here we get m as -1, and here we have m as 2. Now, you're not done, and so that's where people might go wrong. You stop too early. We always need to go back to have an x in our answer, because the first question we're actually solving for x. So we rewrite the m is 3x, so this is 3x equals -1, or 3 to the x equals 2. Now, I'm hoping that someone will catch this, but if you don't, what do you do to both sides? Log base 3. So I'm hoping you now catch it here, at least. Oh. I put a log base 3 on both sides to cancel out the 3. So we get x equals, and what about this? Undefined, right? You can't have a log of a negative. You could notice it here. 3 to some power, what are the answers to that? 1, 3, 9, right? And stuff in between that, but you can't get a negative. You can get fractions if you raise it to a negative power, but you can never get a negative. So, and this doesn't work. So this is undefined. Here, log base 3 of 3 to the x equals log base 3 of 2. So this is x equals log base 3 of 2, although that doesn't work out nice, because 2 is not a power of 3, that's the answer. Now, do you remember if we were going to plug it into a calculator? If you needed an exact answer, how do you do that? Ln buttons on a calculator. What is it? Ln of 2 over ln of 3. The top number over the bottom. Ln of 2 divided by ln of 3. That would give you the exact number. You don't need to write it like this. I'll accept that as an answer, because it is an answer. Okay? And that would be it. We don't need to check it, because the original question didn't have logs in it. Okay, so now you can do section 3.1 and 3.2.